we will start with what is Lisp first. So Lisp is a functional programming language that was developed by designed at MIT and developed by McCarthy. It is based on lambda calculus. It's used in AI research, artificial intelligence, and we use it process data in the list. Whenever you are learning Python, you will also see that what is list and how we process list. So you'll get the idea about this. Then we use symbolic computation rather than numeric computation. We will see another example, another programming language where we use also this type of logical computation or symbolic instead of numeric. And in the list, we have two types of data. We have atoms and list, and using these two data types, we actually represent the data. Now, here's another example that how we actually define the predicate in the Lisp programming language. We'll start with the definition that we have for two parameters. For example, in this one, we start with the define equal list. So you want to compare whether two list is similar or not. So this is list 1 and list 2. Then what is the condition if two list has to be equal? So the atoms of each list, list 1, will have to be equal to the list 2. And if there's no atom in the list 2, okay, we actually go for the next item. So in this again, then we compare the first part of the list 2 with the second part of the list 2. Okay, we take the most significant bits and we take the rest of the list. So here there are two operations. First is the car operation, which returns the first element of the list, and then cdr, which returns the last element of the list. So what we're doing, if both lists are equal, then it's great. If not, we actually compare the first element of list 1 with the first element of list 2, and we compare the last element of list 1 with the last element of list 2, and we keep go on like this. So this is a predicate that actually return true if two lists are equal. It returns nil if the two lists are not equal. So you don't have to memorize how this operation work. It will not come in the exam. This is just to give you an idea. So next is that uh, in the Lisp programming languages, okay, we use lambda calculus. So normally how the lambda calculus looks, so lambda calculus has two parts. One is called the head. Any expression have two parts. One is called the head and it's called the body of the expression, and they're divided into small expressions or functions. So each of the functions are actually inside a first bracket. So this is one function, this is another function, within this function there is another function, or we can say there's a small expression within the function. So this is how a normal lambda calculus looks like, and this is how we represent numericals in lambda. So like for 0 we have lambda f, lambda x, and x. And then you'll see the next ones, they're actually dependent on the first one. So if you want to define 1, which is in that case, you see this is lambda, this part is same. So for all of the cases, this part is same. There's no change. Then what is the difference? The difference comes here. For 0, this is x. For 0, this is fx. That means a function that is depending on x. Okay. Then for the 2 is depend on the previous value. That means it is f of fx. That means this is a function of the previous one. And same way, 3 is dependent on the last one. That means function of fx. So if you just track back, x, the number 1 depends on the function of x. Okay, so whatever you have here, this is the x, it becomes the function of x. Okay, then the second one, it depends on the function of fx. So f function of fx. So gradually it increases. And for the third one, function of fx. So if you just watch it 1 or 2 times, you'll get the pattern that it will keep going on, growing on like this. So the lambda calculus have two advantages or two way to simplify the process. Okay, first of all, you don't need to write any function name. Normally, whenever you write a function, okay, we need to have to semantics or we need to use functions with a name. But lambda calculus, what it can do, it can treat functions as anonymously. Okay, you don't need to have any names for the function. So instead of writing a function like this, you can directly write this. So no names, okay, just xy and this. So this is the first simplification, the rewriting functions anonymously. Second simplification is that it can only use function as a single input. So in one function, if you have two parameters, lambda function, lambda calculus, what it will do, it will convert the function or transform the function of from multiple input to a chain of functions with one input. So let's see this example. So this is a function where you have two input. Okay, you need to give x or y. So we can say we need two parameters. So what they will do, instead of these two parameters, it will divide the function in this way, where this is the first function where you will calculate y, and from the result of this function you will calculate x. Or I can say in this way, let's say x means age and y means name. So first it will transfer the name, it do all the calculation for the function, and then it will transfer the, let's say, age. So this lambda calculus, it removes the name of the functions to handle them anonymously. And number two, if you have a function with multiple parameters like 2 parameter, 3 parameter, 4 parameter, what it will do, it will use a method called currying, where what it does, it takes a function with multiple parameters and make it a chain of function with 1 parameter at a time. That means it will handle 1 parameter at a time, which makes it more simple for the computer. So it can handle 1 parameter at a time. Now, to understand the example of lambda, the Lisp, that why we need this type of programmings, okay, I will explain another program that is we call Prolog. But before going to the Prolog, I want to show you two things, that is evaluation. So Lisp is a programming language that actually pioneered the functional programming. Okay, before that, the functional programming was not that much common. Okay, or the idea was not common. Just think about this, that you have web development. Okay, now before, let's say the first web development language was PHP. Let's say, okay, I'm not saying this is the first one, for example. So before the PHP was available, all the type of web development has to be done, let's say, by C programming language, which was not that easy. Okay, because C actually does not relate to web development. But now after PHP came, the whole process became much more easier. Okay, so we can say PHP is a pioneer for web development, if PHP was the first. I'm not sure whether PHP was the first or not though. Now, so we did not, Lisp was the pioneer in the functional programming language. We did not need variable or assignment. The control via recursion, the conditional expressions were also done here. And and still today, like up to 15 years ago, Lisp was the the most dominant language for artificial intelligence, that is AI. Okay, and the common Lisp that we have here, and the scheme, that is another language that we'll see here. Okay, they are actually contemporary dialects of Lisp. That means one same language but different dialects. So what is a dialect? Let's say that in Bangladesh we speak Bangla, right? But if you go to different areas, you will see that they speak Bangla in a different way. Let's say if you go to Chittagong, they have their own dialect of Bangla. If you go to, let's say, Sylhet, they have their own dialect of Bangla. So like both of them are Bangla language. Whenever they write, they also write the same language, but they have different speaking dialect. Okay, so there are two programming languages. They're still, we use them. One is common Lisp, another is Scheme. Both of them are actually contemporary dialect of Lisp. That means they came from Lisp, similar to Lisp, just a little bit different in terms of implementation. And there are other related programming languages that we will not discuss, that is ML, Miranda, Haskell, but these are also the same type of programming language. Now, so this is the one question. The another question is that how we actually can write Lisp. So before going to writing this, let me show you Prolog, which is a bit easier to understand. Here, so Prolog is a programming based on logic. Lisp was on symbol. Okay, so both of them are not numerically done. So these were developed by two scientists from one of the University of Marseille and another scientist from Edinburgh. Okay, so this is based on formal logic, and this is a non-procedural programming language. Okay, and it can be summarized as being, we can say, instead of saying a programming language, we can say that Prolog is actually intelligent database that can store data and make sense out of data. Also, it has a interferencing process and it's highly efficient, as well as there's a small application areas. So let's say how this Prolog work. Okay, so first of all, let's say this is an example of Prolog. It has three parts. First of all, this is the part where we do the data. Okay, so and here's the logic part, and this is the question. So first of all, what we have here is we're saying that Adam is a man, Peter is a man, Paul is a man, Mary is a woman, and Eve is a woman. So we're basically giving a list of man and woman, list of names, and we are defining the gender. Okay. Then we are defining another thing, that is defining the parent. So we're saying that between Adam and parent, there's a parent-child relationship. So what does this mean? This means this, the first one, Adam is the parent of Peter. So Peter is the son or daughter. Adam is the father or mother. We are not sure who is father and who is the son. Okay. So we are not defining gender here. We're just defining that they have a parent relationship. Then even Peter, they also have a parent-child relationship. Adam and Paul also have a parent-child relationship. So all these are data. And now what is the logical part? In the logical part, we are saying that if someone wants to be the father, okay, the father needs to be a man, and they need to have a parent-child relationship. If someone wants to be a mother, or if someone is a mother, sorry, not wants to be, if someone is a mother, first of all, the mother will be an woman, and they will have a relationship between parent-child relationship. So how it works? So first we ask the computer or the program that find me the father of Paul. So what the program does, it says, okay, I have to find the father of Paul. So first it will go to this one. Okay, it will go here and it will check that what is the condition, what is the condition to become a father. It will see, to be a father, okay, we need to have a man, because man can be father, and we need to have a parent-child relationship, right? So he will ask that, okay, so who is the parent of Paul? If you look here from this database, we have two options for Paul. So Paul have two parents. One is Adam, one there is Mary. So now it will go for the first one. So to be a father, the parent need to be a man. So it will compare that, okay, between these two parents, one is Adam and one is Mary, which one is man? So we can say that Adam is man. So it will return the answer that Adam is Paul's father. Okay. Next, same way, if you ask for who is the mother of Paul, it will come here. It will see, to be a mother, it needs to be a parent-child relationship and an woman. So here you will see the Mary is the woman, so it will return Mary. So if you ask who is the father of, let's say, Eve, so it will come here. So you'll see that there's no parent relationship is given for Eve. There is one is given where Eve is the parent, but for Eve's parent, no information is given. So it will say no information found, because there's no information given here for Eve. If I ask for another person, okay, whose information is not given, it will not be able to identify. But if the informations are given, you can easily find out who is the grandfather, what is the relationship, or you can ask what is the relationship between Eve and Peter. It will answer, then Eve and Peter are father mother or mother child. Okay, so it can take logical decisions like this. Okay, these are not programming or numerical values, these are logic, right? So if someone has to be father of his, there needs to be a man and a parent and so on. There can be other contemporary examples, such as if you watch cricket games or football games, or if you have you'll see that there sometimes they predict something like that, that if this certain person scored 2 goals, if Sakib Al Hasan score more than 50, Bangladesh has high chance of winning. Or like, let's say there's a match going on between Bangladesh India, and they will say that in the last 3 matches, whenever Sakib Al Hasan scored more than 100 runs, Bangladesh won. So this type of logical or pattern finding process, they can be done by Prolog. So I think you can go over this example again, and if you don't understand, I will again discuss it in the next class. So for now, let us go back to the Lisp. Mm. So here again, we're trying to think of a different types of computation, right? The one that we do is not here. So first of all, I will show you one simple example. Then in the next class, I will show you the rest of the examples. So first step, whenever you are working with Lisp, okay, you have to see there are two types of data. One is atoms, this A, B, C, okay, and there's a list. Totally, they are called a list. So how they are actually drawn. So if we take the first example, A, B, C, D, you see a bracket means this is actually the boundary. So in between this boundary, we have 4, A, B, C, D. So what we will do, we will start, this is the first example, okay? So we'll start with an arrow sign. So this is where we start. Each of this will have two boxes. You see, for A, we have two boxes. For B, we have two boxes. For C, we have two boxes. And for D, we have two boxes. The one that is at the last, that is D, will have the ending sign like this. And each of these boxes, you see, for A, there's a two small points. First point is pointing to A itself. The second point is pointing to the B. So it's almost like a pointer, okay? The first one points to itself. The second one points to the next one. B points to itself. The second one points to the next one. And it goes on like this, okay? So like instead of A, B, C, D, if we have A, B, C, D, E, in that case, we'll create one more, okay, which will point to E. And as the E is the last one, it will go, we give a sign like this, and this is E. So this is the simplest one, that is a linear. We don't have any nested brackets here. So we just draw small boxes where each box has two parts. The first part points to itself. The second part points to the next. Okay, so this is the simplest one. So in our next class, we'll see what if we have brackets in between this, okay, how we can draw it. So let me finish here.